So let's go through parallelograms pretty quickly. Parallelograms are quadrilaterals whose sides are parallel, opposite sides are parallel. That's what a parallelogram is. You've been talking about those most of your school career. So we're going to talk about properties and of the sides and the angles, and we also talk about the diagonals. So I've got a little thing down here in blue. It says name some specific quadrilaterals. In the previous lesson, we mentioned rectangle. That's a special type of quadrilateral. A square, which is a special type of rectangle. It's a special type of quadrilateral. We mentioned parallelogram, which is what we have here in this lesson. We mentioned rhombus. We mentioned trapezoid. Those are four-sided figures, quadrilaterals. And we mentioned a kite. And we'll actually be talking about that later in the chapter. So those are just some special types of quadrilaterals that come to mind. For properties of parallelograms, opposite sides are congruent. We see that marked here. Opposite angles are congruent. We see that marked here. We see that consecutive angles are supplementary. And if you think about that, if these two are parallel, cut by a transversal, then those consecutive angles are like the consecutive angles that we talked about back at the beginning of the course, and they have to add up to 180. And that's what it means when it says supplementary. And then finally, it says if one parallelogram, this is 6, down here, if a parallelogram has one right angle, then it has four. Because if you've got one, let's say J, then the opposite angle has to be congruent, and the consecutive angles have to be supplementary. So that makes, you can easily see how everything has to be 90. But those things are important to remember. Opposite sides are congruent. Opposite angles are congruent. Consecutive angles are supplementary. And if you've got one right, they're all right, because that's how that would work. Let's take to this. It says in parallelogram, that's our symbol there, in parallelogram ABCD, suppose that the angle B is 32. I always like to mark. If you don't already have the drawing, then do the drawing and mark. It says CD is 80 inches. That's the length of this side right here. And BC is 15 inches. It's the length of this side. And it asks us to find AD. This. Well, because this is a parallelogram and opposite sides are congruent, this is 15 inches. So I didn't need the 32, I didn't need the 80 for that problem. But I do have the same setup, and they tell me this is 32. They tell me that this is 80 inches, and they tell me this is 15 inches. And they ask me for angle C. Angle C is here, right? They ask me for angle C. Angle C is here. And since angles B and C are consecutive, they're supplementary. They add up to 180. So since you got one that's 32, if you subtract, you got 148. Same picture, same thing. This time they're asking us for angle D. Since this is 32, if you remember from our original picture, and of course from here, opposite sides are congruent, angle D. The measure of angle D is 32. So we finally switched to a different picture. But they do tell us it's a parallelogram, because you can't just tell by looking. But they tell us it is a parallelogram, and it says find AB, which is the length of this side here. Since this is 30 and these are congruent, it's 30. Answer C. asks us to find the measure of angle C, which is this one here. Since this is 36 and opposite angles are congruent, it's 36. So these are really, really easy. You just got to remember the rules. That's what you got to do. So here, we're asked to find the measure of angle D, which is this angle here. Now, since this is a parallelogram, consecutive angles like A and D have to add up to 180. They're supplementary. So if this one's 36, how much is left for this one? They got to add up to 180. So you can subtract, and you find out that it's 144. Answer C. Now we talk about the diagonals. This is important. This is important because we're going to use this in a lot of different things later on. These little rules, these little things. You're solving a problem. You've got it. It's weird, but you just kind of got to know all this. So the parallelograms, the diagonals of parallelograms that we have here, bisect each other. So if ABCD over here is a parallelogram, then AP is congruent to PC. And DP is congruent to PB. That's just how it works. They bisect each other. And that can be nice to know. 6.8 says if a quadrilateral is a parallelogram, then a diagonal separates the parallelogram into two congruent triangles. Because we already knew these two are congruent to each other. We already knew these two are congruent to each other. And of course the diagonal is congruent to itself. So the two triangles are congruent by side, side, side. Nice. So we come in here and we're doing problem solving now. And they've got all kinds of letters here. And you can look at that and make your eyes hurt. But they want us to find the value of R. So I'm looking at here and I see an R right here. And R appears to represent the length of this side, which is congruent to this side. Because it's parallelograms, opposite sides are congruent. So that means 4R equal 18. Divide both sides by 4. R is 4.5. What it asks us to find? The value of R. 4.5. Same picture, different question. They asked us to find the value of S. Well, here's S. Okay, and S, it would appear, is this piece. But it's also this piece. Well, 7S plus 3 is the red piece, and 8S is the yellow highlighted piece. Well, what do we know about those two pieces? In a parallelogram, those two pieces are congruent because diagonals bisect each other. So that means 8S is equal to 7S plus 3. So S is equal to 3. That's the value of S. If we put the 3 back in here, we get 24. If we put the 3 back in here, we get 24. And that would have to be that way, of course, because they're congruent. So we find out that S is 3. Same picture. In this case, they asked us to find the T. Here's a T. T would appear to be the measure of this angle right here, this piece. Now, I want you to kind of notice is the parallelogram, two congruent sides cut by a diagonal. We would call it a transversal, but that means this alternate interior angle is congruent to this alternate interior angle. So the 2T is equal to 18. T equals 9. That's the answer. So we get a different picture. We ask a different question. Here we're asked to find the x, but really it's just these relationships. So you can see we're given this piece here to be 6x plus 2, and this piece here to be 4x plus 12. Well, what we know is those two pieces are congruent because the diagonals bisect each other. So that means 2x equal 10, x equal 5. That's the value of x. That's what they asked me to do. I can put the 5 back in right here and get 20 be 32. Put 5 back in here and it'd also be 32. And just sort of check, prove, make sure that we know that x is 5. By the way, that was what they asked for, was the value of x, right? Value of x is 5. They did not ask us for the length of side, although they could have. So the p, there's the p. It's got to be equal to that. It's d. It's really that easy. It really is that easy. We could go on through these. Let's look at this one. It says, what are the coordinates of the intersection of the diagonals of parallelogram NMPR? So let me graph this. Negative 3, 0, that's the M. Negative 1, 3, that's the N. 5, 4, that's the P. And 3, 1, that's the R. So it would appear that this is our parallelogram. Oh, by the way, we could take the time right here to prove that the slopes are the same, because if they're parallel, like if this side is parallel to this side, then they have to have the same slope, rise over run. You can look and see the slope is 3/2 of both of them. We could go on and check the NP and the MR as well. But that wasn't the question, so let me get back to the question. So what they want to know is, if you draw a diagonal here, and you draw a diagonal here, where do they cross? Where do they intersect? Right? What are the coordinates of the intersection of the diagonals? Well, I could have drawn it on a bigger graph. I could have. But here's the key to all of this, is they bisect each other, right? So let me go back to my picture, and let's talk about the bisecting. In fact, yeah, let me just do that. Let me change just a little here. So what we want to know is the point of bisection. Well, let me talk about MP, segment MP. M is at negative 3, 0, right? And P is at 5, 4. I mean, we know that from up here. So when NR comes scooting across through here, it cuts MP into 2 equal pieces. Where does that happen at? At the midpoint. So now let's talk about midpoint. How do you find the midpoint of a segment? And earlier in the year, I told you, think average. Think average. So what is the average of a negative 3 and a positive 5? 1. What is the average of a 0 and a 4? 2. 1, 2. Does that appear halfway right? Does to me. 1, 2. So most of the rest of these are just similar practice of the same thing.